Good morning or good evening, depending on when you are watching this video. Hi guys, we are going to just do a quick overview of some learning that we worked through this week with some trigonometry. So what I'd like to do is I want to go through and do some additional examples with you and see how this works out for giving you that little extra bump, that little extra help you might need to understand how to work with these trig functions that we've been working on. So a really good place to start, just because we're going to be using this kind of over and over again, is to remember that sine is equal to opposite over hypotenuse, that cosine is equal to adjacent over hypotenuse, and that tangent is equal to opposite over adjacent. So we have this acronym, and we are working on page 10 from your workbook if you'd like to follow along or work along with me, or maybe even just try some of these problems yourself first. If you'd like to go down that road and try that, you can do that as well. Okay, so we're just going to do 12 and 14 over here just because they happen to have a little extra space. So when we're finding a missing side, remember we're going to go to the angle that we know, our reference angle, and we are going to look at what side we have and what side we want to figure out. So with respect to this reference angle, the hypotenuse we know is always the hypotenuse. It's always across from the 90-degree angle. We're not working with that one in this particular example, which means that really both cosine and sine are kind of out of the picture in terms of our choices because we're not working with the hypotenuse. So let's look at what we do have. We have the side adjacent. Get a pen going here. We have the side adjacent to my angle. And remember I said that if you would like to label these to help you out, just do that. Label that one. This one, the toss across over here, x is the opposite. So when we set up our proportion, we are going to use tangent, opposite and adjacent. So we're going to say the tangent of 61, I'm just going to put that over 1, is equal to opposite over adjacent. Okay, so when we cross multiply, we know that x, 1 times x, is equal to 16 times the tangent of 61 degrees. All right, and you want to make sure your calculators are in the right mode, that they're in degree mode when you're working through something like this. And we're going to take our calculator here real quick and just try that, and you guys can try it at the same time. It's always a good idea to make sure your calculator is working correctly and that you know how to use your calculator correctly. And what I got for x was equal to 28.86. And you can round to the nearest tenth or whatever it requires you to round to. Oh, there it is, round to the nearest tenth. So if we're rounding this to the nearest tenth, it's going to be 28.9. Okay? All right, let's go on to this next one. We have a couple more examples as we work through our video today. So let's take a look at this one. I'm going to put this one in a different color so it kind of keeps it separate. Here's our reference angle. It's 52 degrees. We have this side that we want to know that is right next to our reference angle. So that's the adjacent side. And 16 is our hypotenuse. Again, if you need to label, go ahead and label. But adjacent and hypotenuse, that is going to be using cosine. So we're going to say the cosine of 52 degrees is equal to adjacent, which is x, over hypotenuse, which is 16. Again, our algebra on this one's pretty straightforward because we can just take 1 times x and get x is equal to, and we're just going to multiply 16 times the cosine of 52. Don't forget that sometimes, especially when your variable that is unknown is on the bottom of your fraction, you're going to have to divide. So just be careful of that. That is sometimes a mistake that is easily made, to forget to divide and your proportion. Okay, so on this one we got 9.8. So x is equal to 9.85, so really 9.9 if we round to the nearest tenth. All right. Moving on, if you need a time to process or to kind of pause and get organized, certainly make good use of that time. We're moving on to problems that you'll find on page 23 of your workbook. And in this case, we're working backwards. This is a working backwards situation, and we are actually going to try to find the angle given these two sides. And the two sides I see here from my reference angle are the opposite and the adjacent. So I want to pick the trig function tangent of question mark. What should we call question mark? Should we just leave it as a question mark? We could do that. That's our little variable right there. Is equal to opposite over adjacent. And we learned that to solve for a missing angle, we're going to take the inverse tangent of our ratio to work backwards to that question mark. So let's play that into our calculator here real quick and see how tangent inverse of 5/8 treats us. We're rounding to the nearest degree, and we should get, if you guys did this one with me and you did it correctly, you should get 32 degrees was the question mark angle. Okay. So the really, really big thing I want you guys to be remembering and trying with this work is choosing the correct trig function, right? We're really trying to choose that correct trig function. Let's come down here. Instead of calling it question mark, let's call it theta. Okay, we've talked about using other variables for your angle. So there we go. So with respect to our reference angle, right here, if we shoot across right there, that's going to be the side opposite. And we also know the hypotenuse, so you ask yourself, which trig function uses opposite and hypotenuse? So hopefully you guys are thinking, oh, that's the sine of theta is going to equal the opposite over the hypotenuse. And of course, the inverse sine is how we get the angle that is missing. So on your calculators, you're going to take the inverse sine of theta. And hopefully you guys are working right along with me so you can double check your work. What did we get on this one? Nearest degree, 39.29, 39.3. If we go to the nearest degree, probably theta is equal to 39 degrees. Boom. All right. And we're done with that piece. So far, let's just kind of do a little recap. I'm going to scroll you back right here, okay? In this case, where we're using the sine, cosine, and tangent buttons, so we're using the sine, cosine, and tangent buttons, this is when we know the angle, and we're trying to find a missing side, is when we use our sine, cosine, and tangent buttons. And then these examples where we're trying to find the missing angles, this is where we're using our inverse. Okay, tangent. And that's if we're finding a missing angle. And last but not least, the other learning target that we covered this past week were special right triangles, okay? And a lot of times what I'll do is I'll draw my special right triangles and draw kind of the relationship that I know is going to happen with my special right triangles. Here's my 45, 45, 90. And I know if my two angles are equal, then my two sides have to be equal, and then my hypotenuse is always that leg times the square root of 2. For my 30, 60, 90, and it really doesn't matter which way we draw it, I'm going to go ahead and draw it this way. And not every triangle is a 30, 60, 90 that looks like this. It has to be labeled 30, 60, 90 or 45, 45, 90 to use these relationships. We know the short side is x. The hypotenuse is twice as big, right, because it's part of that equilateral triangle that we knew. And then our altitude is x times the square root of 3. So You might want to just pause this video real quick. We're almost to the end of it, but if you pause real quick and try these problems, these are on page 12, and I don't know that you've done these problems yet, so if you'd like to kind of test yourself, you can pause the video, try these problems on page 12, and then turn it back on and check your answers, okay? Because I'm going to go through these pretty quickly here in about 2 shakes. All right, here we go. We're back. Hopefully you gave it a little shot on your own. Here, y is equal to 7. Hopefully you got those two sides are equal, which makes the hypotenuse 7 root 2. Over here, it's a 45, 45, 90 again. This one's a little trickier because we have to work backwards and divide by the square root of 2. Did you get that? That one's a little harder, right? So remember, working from the hypotenuse backwards, we're going to have 2 divided by the square root of 2 as the length of our two sides. And real quick, let me show you how to rationalize a denominator. If you have a square root in the bottom, and we'll practice this some more, what you can do to get that square root out of the bottom of your fraction is to multiply by 1. But we've chosen a form of 1 that's going to get rid of our square root in the bottom of our fraction. So it looks like this: 2 times the square root of 2, and root 2 times root 2 is root 4. I'm just going to show you this step because that's how you get that. But we know what the square root of 4 is equal to. So I'm just going to pop down here. We know that the square root of 4 is actually 2, and then these 2's cancel. Okay, 2 divided by 2 is just 1. So the final answer you would have gotten, okay, back here is root 2 and root 2 for 38. Okay, a little bonus question there. That was a tricky one. Last couple. Longest side, hypotenuse. These next ones have to do with your 30, 60, 90 right triangle. 4 is going to be exactly half. This one should be 4 root 3. Don't forget it's root 3, not root 2. Short side is 4. That's half in our equilateral triangle, right? So that means the hypotenuse has to be 8 and 4 root 3. There you go. All right, guys, hopefully these examples have been helpful to you. Have an awesome rest of your week. Take care.